25 grams of ammonium nitrate solid is dissolved in 50 milliliters of distilled water, and the temperature of the solution decreases by 24 degrees Celsius. What are the three processes involved in the dissociation process, delta H1, delta H2, and delta H3, and what statement can be made about their magnitudes for the dissociation of ammonium nitrate? So whenever a solid dissolves, there are really three separate processes that are all kind of happening at the same time. The first process, which we call delta H1, or step 1, is that the solute particles have to separate from one another. In an ionic crystal, this would be equivalent to the lattice energy. Or if you have a molecular solid, you have to overcome whatever intermolecular forces are holding that molecular solid together. But either way, you're going to have to break bonds. You're going to have to break electrostatic attraction. And because you are breaking bonds, this process of breaking apart the solute is always endothermic. So delta H1 is always a positive value. The second thing that happens is that when you are going to dissolve something in a solvent, the solvent molecules have to separate from one another in order to create room or space to kind of fit the solute particles in between them. And so again, we are separating molecules, we are overcoming intermolecular forces, and so delta H2 is also an endothermic process. And so it will always be a positive value. Step 3 is often called the heat of hydration. What that means is that the solute particles are being surrounded by water molecules and they're forming bonds with the water molecules. So this step we call the heat of hydration. And because we are forming bonds, anytime you form a bond, even an intermolecular bond, that process is going to be exothermic. And so this final step is our exothermic step, which means that our delta H3 is always going to be negative. So the statement that we can make about the magnitude of these processes is that delta H1, which is the heat that's required to separate the solute particles, plus delta H2, which is the heat that is required to separate the solvent particles, those two things together, those are our two endothermic processes, have to be larger in magnitude when they're added together than the amount of heat that is released. This is our exothermic value. But because we're talking about magnitude, we have to use absolute values here. So really what this is saying is that we are putting in more energy, separating the particles, than we are getting out when the solute and solvent particles come back together. And so the overall process, which is called the enthalpy of solution, delta H solution, has to be greater than 0 because the net energy is positive. We are putting energy into the system. So why does this process happen spontaneously? Why is it thermodynamically favorable? And the reason for that is because this process is what we call entropy driven. In other words, the change in entropy, the increase in entropy when we have a solid that becomes aqueous is drastic enough that even though the overall process is endothermic, the reaction will still proceed in the forward direction.